Hey guys, back continuing on in chapter 9, and probably not going to be done, but close to done with 9. Like I keep saying the same thing. But of course, we all need to know jokes. We need jokes. So here we go. I need them. What do you get when you cross a bat and a bell? It's a riddle. A dingbat. A dingbat. Let's see. How can you get 4 suits for $1? How can you get 4 suits for $1? You can buy a deck of cards. And the last one, why don't oysters give to charity? Because they're selfish, shellfish. Oh my gosh, when you have to explain the jokes, they're not very good. Okay, so we're going to pick up back where we were. So we went to hybridization of all the main, and again, hybridization is really just the explaining of dots. And we said if you do the dot structure, count the electron domains. Okay, if there's 2 electron domains, the hybridization is sp. If there's 3 electron domains, the hybridization is sp2. If there's 4 electron domains, it's sp3. If there's 5, it's sp3d. And if it's 6, it's sp3d2. Now we're going to get into multiple bonds. So let me pick up here where I left off and explain this. And I was saying this in class, but I'll go through the chemistry here, the logic, how this works. But if you have a double bond, always the second bond. The first bond is going to be the hybridization like we've had. We're still going to do the same process. We're still going to count the electron domains, and we're still going to count the electron domains, and that'll determine the hybridization. But there's going to be one extra bond if it's a double bond. Well, that extra bond is going to be called an unhybridized P, and I'm going to show you that, and you can kind of see that on this page here. If there's a triple bond, the first bond is always going to be part of the normal hybridization, but then the second and the third bond will be unhybridized. Get that? So they don't hybridize, unhybridized P's, and we'll look at that in this chapter, or as we finish this chapter. Okay, so I'm going to go to the board. So I'm going to do the same exact process that I've been doing. So I'm going to do C2H4. This is, again, a classic organic molecule, which, again, depending what's going on, after the AP test, we might spend a couple days just doing some basic organic chemistry. So if you ever take it down the road, at least you got the first day or two of your organic chemistry class covered. So what's going to happen here is carbon has 4 valence electrons. There's 2 of them. Okay, and then 4 H's. So here, and H is here, and then it bonds there. Okay, and again, we've done that moleculing a couple times, and hopefully that makes sense. So if I kind of clean this up, so I've got carbon double bonded to a carbon, and then each carbon is bonded to H. So if we go back to what we've already learned, so I did the dots, and if I count the electron domains around, I have 2 central atoms. Around the carbon, there's 1, 2, and 3. There's 3 electron domains. So if there's 3 electron domains, so that would mean it's sp2 hybridization. It's sp2, and that is true of this as well. There's 1, 2, 3 electron domains. So let's look at carbon. So carbon is its electron configuration, 1s2, 2s2, 2p2. That's its electron configuration. So if I, again, do the orbital diagram, so here's the 1s, here's the 2s, here's the 2p's, 2p2, and then there's 2 in there. So what we talked about before was electron promotes, so it promotes up here. But because this is 3 electron domains, it's sp2. So one of these goes up here. And so these 3 hybridize. This happens in multiple bonds. So these 3 hybridize. So what I've got then is I've got 3 half-filled sp2 hybridized. But then I've got this right here. And this is a P. And this is why they call it unhybridized. Unhybridized It's because it hasn't hybridized. It did not, it's not like these. And so in this, and the same thing happens with both carbons. So 1, 2, 3 electron domains. So the way you would describe the hybridization here, we're talking about with the carbons, it is sp2 hybridized plus 1 unhybridized p. Okay, and you'll see that. You'll see that on this Tinker Toy activity that we're going to do this week, and you're going to see this on the quiz. You're going to see it eventually on the test. When there is a double bond, the first bond is part of the normal hybridization, but the second bond becomes this unhybridized piece. So if it's a double bond, that second bond would be 1 unhybridized p. And then in class on Tuesday, we'll look at one that's got a triple bond. Well, if there's a triple bond, the first bond, again, is the normal hybridization, but then the second and third would be unhybridized p. So again, something we're going to talk about again as we conclude chapter 9 later this week. And again, it's a little bit confusing, I know. Okay, so now back to the notes. Okay, the next thing, again, we are close, but we still have a couple more things to do in this chapter. Okay, so multiple bonds. So the first bond is the normal hybridization, and the second bond is would be 1 unhybridized p. If it's a triple bond, it'd be 2 unhybridized p's. Okay, we'll come back and look at that. Okay, sigma bonds versus pi bonds. A sigma bond is the bond where the electron density is directly between the two bonding atoms. So in a double bond or a triple bond, I always think of the single bond being the sigma bond. The first bond in the double or triple bond is the sigma bond. It's the stronger bond. The sigma bond is the stronger bond. And the pi bond is where the electron density is above or below the bonding atom. So that in a double bond is the second bond. So the pi bond is weaker than the pi bond is weaker because it's not between the nuclei. It's above the nuclei of the atom, so it's a weaker bond. So the sigma bonds are stronger and the pi bonds are weaker. Okay, now how we count these. So all the single bonds, or the first bond in a multiple bond, is a sigma bond. Okay, I'll say it again. I'm going to do a couple of examples. But all single bonds are sigma bonds. And the first bond in a multiple bond is a sigma bond. So in a double bond, there's 1 sigma, 1 pi. The pi bonds are always the second and third bond in a triple bond, or in a double or triple bond. So the pi bonds are always the second or third bond in a double or triple bond. Okay, all that being said, the best way to do that is to do examples. And you can see there in the diagram the sigma bond and the pi bond. Remember, sigma bonds are stronger than pi bonds. Okay, so here's an example. A couple of examples. So counting, and again, this is something that you guys, it's really not that difficult to do, but to count the number of sigma bonds and the number of pi bonds in a bond. So let's say we've got this molecule right here. So we get classic organic molecule, hydrocarbon. Okay, it's like this. And so what we're going to do here is we're going to count the number of sigma bonds, and the number of pi bonds. Okay, so what I was trying to say there is a sigma bond are all the single bonds plus the first bond in a multiple bond. Okay, so all the single bonds and the first bond in a double or triple bond. So counting the sigma bonds, 1, 2, 3, 4, 5, 6, 7. Okay, so we'll do that again. Okay, so it's all the single bonds, and it's the first bond in a double or triple bond. So 1, 2, 3, 4, 5, 6, 7. So 7 sigma bonds. Now the pi bonds are always the extra bonds, the second bond in a double bond or the second and third bond in a triple bond. So here, that would be 1, 2, 3. So this organic molecule has 7 sigma bonds, 3 pi bonds. Okay, let's do another example here. I'll just leave it up here for a second. And if you guys want to try this stuff, I've got H, C, H, H, C, and then triple bond to an H like that. Okay, so count the sigma bonds and the pi bonds. Okay, take a minute and see if you can do that. So the sigma bonds, again, are stronger. They're the bonds that are directly between the nuclei, so they're held tighter. The pi bonds are above the plane of the molecule. They are weaker. The sigma bonds are all the single bonds, and they're the first bond in a multiple bond. So 1, 2, 3, 4, 5. Oops, I didn't write that right. I'm sorry. This cannot be the case. I've screwed up. There we go. Let me do that again. Okay. I didn't write that out right. Now let me go back and let me go back. I need to correct this. I'm going to go written down here on my sheet. Okay, so the sigma bonds are the single bonds. So 1, 2, 3, 4, 5, and then the first bond in a double bond. So sorry about that. And then the pi bonds are in a double bond. They're the second bond. So there'd be 1 in a triple bond. There would be 2, and so 1, 2. So again, the sigma bonds 1, 2, 3, 4, 5, 6, and then the pi bonds would be 1, 2. Okay, and I'll come back and we'll look at that again. As a matter of fact, the next slide we'll look at that again, but counting sigma bonds and pi bonds. Okay, a little bit more. Try and maybe do one more page. That'll be a good place to kind of, on Tuesday, we'll wrap up chapter 9 and keep saying, like I said, I keep saying the same thing. I move into chapter 10. Okay, sigma and pi bonds. This kind of shows you the planes of the sigma bonds and the pi bonds. And I've tried to explain kind of to me the way I always remember that. Okay, let's do this. This will be the last one we'll do. The last slide we'll do, and then we'll finish up chapter 9 tomorrow on Tuesday. And we will definitely move into chapter 10. Okay, so what type of hybridization? So here we're going to go back. We'll do dots. We'll do shapes, bond angles, polar, nonpolar, and the hybridization. Both the carbon and oxygen are hybridized. How many sigma, and then the sigma and pi bonds in this? Here we've actually done, I've already done for you guys the dots. The dots. One thing I left out here, I'll show you. So one thing I left out here is the non-bonded electrons on oxygen. So it should be like that. I left off these non-bonded electrons there. Okay, so now to count the electron domains, there's around carbon, there's 1, 2, 3. So 3 electron domains. And here is what I was talking about 5 minutes ago, or a little bit more than that, is that in a double bond, the first bond is part of the normal hybridization, which would be sp2, because there's 1, 2, 3 electron domains. 3 electron domains is sp2 hybridization. But the second bond is an unhybridized p. Okay, so the bonding around carbon, or the hybridization around carbon, is sp2 hybridized plus 1 unhybridized p. And around the oxygen, again, if I count the electron domains, there's 1, 2, 3. So I have the same thing because I have 3 electron domains. It's also sp2, the normal hybridization for the first bond. And then the second bond is 1 an hybridized P. Okay, and we'll come back in on Tuesday, tomorrow in class. I will do one more like that. And then if I wanted to go back and do how many sigma bonds and pi bonds. So the sigma bonds would be 1, 2, 3. So all the single bonds would be a sigma bond. And then the pi bonds would be in a double bond, there would be 1, and in a triple bond, there would be 2. So, okay, I think that is a good place to stop. And again, we're going to finish up chapter 9. We're going to move into chapter 10. Your quizzes are due on Wednesday. So if you have questions on those, let me know. We can Google Meet sometime on Tuesday and go over whatever questions you guys have. So, hey guys, have a good day. I will see you Tuesday.